Hey guys, welcome to a next set of notes. I have another joke that my son came up with. We were playing that game, Sharks and Minnows, with his class when I went to go visit. And he came up to me and he goes, "Mommy, what is a shark's favorite game?" Well, what is it? He says, "Swallow the leader." So, super cute. Share it if you like. Let's go ahead and get started with today's notes, though. So today, if you take a look at it, it says Intro to Scatterplots and Correlation. And so we are beginning our unit for data analysis. To talk quickly about a scatterplot, it is a graph with points plotted to show a relationship between two sets of data. A lot of times this is called bivariate data. It can help decide if two sets of data are related. So correlations, this describes a relationship between two sets of data. So there's different types of correlation. There's positive association, negative association, and no association. Then we have linear versus nonlinear association. And so it's whether it would create a straight line or not. So if we take a look at our first one, we see that right around those sets of points, we could create something called a line of best fit. And so this would be a linear association. Then I have another set of points. And so again, I could create a line of best fit. And this would also be a linear association. And then my last set of points, I could again create a line of best fit, but when I do this, this looks a lot like a parabola, doesn't it? So this is called a non-linear association. Okay. Now just to kind of recap what we have going on with what I talked about up here at the top. Right here, this is a no association, also known as no correlation. Here we have nonlinear correlation. I write too big, correlation. Here we have a linear correlation, and we will talk more about this as we get a little further along in this unit, but this is called a weak linear correlation. And hopefully you can kind of make some sense out of this. The points are not very tightly around this line, but then right here we have what is called a perfect or strong linear correlation. Okay, because our points are right where we would create a line of best fit. Now just to talk about a few other things, we have something called clustering and an outlier. And I have some examples of that. A cluster is a set of closely grouped data. And if you look over here, this would be considered my outlier. It is not close to the rest of the data. Data may cluster around a point, like so, or along a line, okay? And so when it's clustering along a line, we could also create that line of best fit. So they work hand in hand on that. Let's go ahead and flip this open. Okay. We are going to talk some more about correlation. So we're going to talk about whether they have a positive, a negative, or no correlation. So before we get into this, real quick, I'm going to talk about how we have these graphs. And we're going to talk about just quadrant 1. So these are positive x values, positive y values. So when we decide whether we have a positive, negative, or no correlation, it's always going to be as our x increases. Now, as a reminder, your x-axis, this is your independent variable. And I know you've talked about this in your science class. And so it's how your as your independent variable is increasing, what does your dependent variable do? Does your dependent variable also increase? Does your dependent variable decrease? Or is there no relationship at all? So for our first one, we have the number of hours a plane is in flight and the miles flown. So as our plane is in flight, we see that the miles flown also increases. So this is called a positive correlation. Then for our second example, the number of hours in flight and the number of passengers. So the longer you are in flight, do the number of your passengers increase? No, they can't just randomly land onto a plane in the sky. So this one is no correlation. Our last example, the number of hours in flight, again, I'm talking about a plane, and the number of gallons of fuel remaining. So hopefully you're like, oh, well, the longer you're flying, the less fuel you have. So as one increases, the other one decreases, and so this one is called a negative correlation. Okay, let's try a couple more examples. Number 4 is the size of a household. When I talk about household, I'm talking about like the number of people that live in that house and the amount of a water bill. And so think about this. The more people you have that live in a house, the water bill should also increase. Okay, so there would be a change. You got more people flushing the toilet, taking showers, brushing the teeth, etc. So this would be a positive correlation. Number 5, the number of songs on a CD and the cost of a CD. So the more songs that you have, does the cost of the CD go up, down, or no change? And so hopefully you think about, well, maybe a classical CD versus the newest CD out by your favorite artist. That's what's going to make a change in the cost, not necessarily how many songs are on there. Price of the cost of a CD is going to be the same, or to make a CD will be the same. So this is called no correlation. And then number 6, the outside temperature. Okay, so as the outside temperature increases, as it's getting warmer, especially as we're heading here from winter into spring, the amount of the heating bill. So you think about it, like in January it's very cold, right? Very cold. My heating bill is very high. Come April, we're hitting like the 50s and 60s, getting a little warmer. My heating bill is probably not expensive. Come August, it's not cold at all outside, so we're all the way over here. And my heating bill, well, I don't really have one. Okay, so this is called a negative correlation. So what I'm going to do is the last 3 with correlations. So 7, 8, 9 we'll do in class, just so we can kind of talk some more and make sure we understand the basics of correlation. So again, this is the basics. Next, we have the line of best fit. This is a straight line that comes closest to the points on a scatter plot. So if you don't have a ruler, snag a ruler so we can get some good straight lines of best fit. This is very important to make sure you have a ruler. So let's go ahead and start with A. And so you see the darkened points on here on my graph. Is there an outlier? If so, what is it? Here are my points. They're all kind of scattered together, so we would say no, no outlier. Then draw the line of best fit. When we are creating our line of best fit, we are going to create it so we have about the same number of points above our line as below our line. And it's okay if some of our points go through our line, okay? So in this one, hopefully you guys realize, well, we're not all going to have the same line of best fit because there's something called human error involved. So I don't know, right around here. I might have mine go right through 60. Make sure when you create your line of best fit, it goes through the y-axis and all the way to the other end. Actually, that's not a very good line of best fit, so I'm going to erase that. I'm kind of far from my more north points, so we'll try this again. Maybe something more like this. That's why, you know, those see-through Oh my goodness, I cannot get this today. I should just show you my answer key because it looks great. Here's my answer key. Doesn't that look great? So we'll try and mimic that. One last time. Yeah, I was saying a clear ruler. I need one of those. So this might work. We'll go with it, okay? Yeah, so I have 3 below, about 4 above. I'm going with it. So got that done. What type of correlation is a scattered plot? So as my x increases, my y increases. It's a positive correlation. The other thing that I want to point out, notice that it's also called a positive slope. So there is that connection right there. The next thing we're going to do is describe the association. So as the number of hours studied increases, okay, we'll see our exam grade also increases, and we'll write that down. And then what exam grade would you expect after 8 hours of studying? So what we're going to be doing is we're going to be solving this 2 different ways. So the first way, we're going to create an equation for our line of best fit and substitute 8 in for x. Okay? But we are going to actually do that on tomorrow's notes. So we will do that on our next set of notes. Today's notes, what we're going to do is we're going to just read it off of our graph. So here I have 8 hours studied. I'm going to go all the way up, right along that line. Here I'm at, and that would be an 85%. So after 8 hours of studying, I would expect an 85%. Let's try this again. So down here, I have my time for my x-axis, my independent variable. Distance is my dependent variable. A says, is there an outlier? If so, what is it? I do. I have one right there. Okay, we're going to mark that as yes. And the point is 8, 5. So we'll write down just 8, 5. Draw the line of best fit. Again, make sure your line goes through as many points as possible. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Ignore your outlier when creating your line of best fit. So with 8, that looks about good. Okay? Then, what type of association? So we have another positive slope. Also notice as my time increases, my distance increases. So this is considered a positive association. I know I said association and I'm writing correlation, but they are both considered the relationship. So in this case, we can use both vocabulary terms. Next, we're going to describe the association. So as the minutes increase, the number of feet increase. And so we'll do the same thing after 1 minute. How far would you have gone? So we're going to use our graph this time to help us out. After 1 minute, I went 3 feet for my line of best fit. You guys might have something else. Again, this is like human error making our own line of best fit. Later on, we'll use graphing calculators to find that exact line of best fit. But we'll go ahead and write in that after 1 minute, 1 minute, I traveled 3 feet. Okay. Hey, Hey, that's it for today's notes. I know that there still is a back. Okay, so we still have these two. We're going to maybe do this in class the next time I see you. And, again, this way, answering questions at the same time. So make sure you are coming to class with your ruler and with a calculator. All right, that's it. See you guys next time.